Welcome to dNAxt. We are discussing class A subnetting, and in this series we are going to discuss slash 26 in this video. So slash 26 means there are 26 bits that are assigned to your network and remaining 6 bits are of your host. Okay, now out of 26 bits, 8 bits are your default network bits. These belong to major network. Okay, and the remaining 8 plus 8, 16, 17, 18. 18 bits you have borrowed from the host portion, which are known as subnet bits and which are responsible for subnetting your this IP. So let's talk about how many subnetworks we will get. That is 2 to the power x, where x is number of subnetwork bits, and in this scenario there are 18 subnetwork bits. So total subnetworks you will get, those are 2 lakhs 62,144. So you are breaking down your major network into these many sub networks. How many hosts per sub network? That is 2 to the power 6 minus 2. 2 to the power 6 is 64. 64 minus 2, 62 actual IP addresses which you can assign to your host or your endpoints. Why we are subtracting 2 from over here? Because in each subnetwork, one will be your network ID, another will be your broadcast ID, and these IDs you cannot assign to your endpoints. What are the valid subnets? That is 256 minus, let's calculate the subnet bit value over here. First bit value is 128, second is 64. So 128 plus 64 is 192. So 256 minus 192, that is an increment of 64 will be there in the fourth octet, increment of 64 in the fourth octet, increment of 1 in the third octet, and again increment of 1 in the second octet. So let's write down few of the subnetwork. We will start with the given IP address, that is 10.0.0.0 slash 26. Then increment of 64 in the fourth octet, 10.0.0.64. Then 10.0.0.64 plus 64, 128. 10.0.0.192. When you add again 64 in this, you will get 256. So increment in fourth octet in this for writing next subnet is not possible. So we'll do increment in the third octet, and increment in the third octet is of 1. So 0 plus 1, 1. So 10.0.1.0. 10.0.1.64, 10.0.1.128, 10.0.1.192, and then 10.0.2.0. Okay, this will go on till you get 10.0.255.192. Now, if you add 64 over here, you will get to 256. So, increment in fourth octet is not possible. If you add 1, because in third octet, increment of 1 is taking place. So, if you add 1 over here, again, you will get 256. So, this is also not possible. And in this case, you will add 1 in this. Increment in the second octet will take place now. And hence, the next subnet will be 10.1.0.0. Next to that will be 10.1.0.64, 10.1.0.128, 10.0.192. Okay. Now 10.1.1.0, 1.64, 1.128, 1.192, then 2.0. So for 10.1, this whole process will repeat till you will reach 10.1.255.192. then it will become 10.2.0.0. Okay, this will continue till you reach 10.255.255.192. This will be your last sub network, because you cannot do increment of 64 in the fourth octet, that will give you 256. You cannot do increment in the third octet of 1, because that will again give you 256, and here also you cannot do increment because this will give you 256. Okay, so in any octet you cannot do the increment. That means this is your last subnet. Broadcast ID for this subnetwork will be 10.255.255.255. Simple. Always remember, for writing last subnetwork, you will write first in first octet major network number, and in the last octet where you are doing increment, the same numbers will repeat, which are subnet bit values. So subnet bit values will repeat in the octets where increment is taking place. Okay, and that will be your last subnetwork. Fine. So this is all about R/26. Before we end up the video, let's write down few of their broadcast ID. 10.0.0.63. Okay, let's write it. 10.0.0.63 is the broadcast ID. Right? First valid host will be 10.0.0.1, and last valid host will be 10.0.0.62. Right? So from 1 to 62, you are getting 62 IP addresses. This is your network ID, this is your broadcast ID, this is your starting range, this is your end range, and between 1 to 62, you are getting IP addresses which are available to be assigned to the host. Okay. So this is all about /26. We'll be discussing /27 in the next video. So stay tuned with dNAxt. Thank you.